Let's continue our discussion about the dictionary. Indexing. Indexing should be straightforward, but it's good to notice it. Here we are defining a dictionary that has a key Mustafa to the key Saad, and key 1 and key 3. Key 1 has a list, key 3 has a list of lists. Now, if you wrote dictionary of Mustafa, it would give you a sequence string Saad. If you wrote dictionary Mustafa, then column -1, then now we get the last character here, which is D. Now dictionary of 1 will bring this list here, and then applying another one will get the second value here, which is 5. In a similar way, dictionary of 3 get this list. Now using this list, dictionary of 1 get this list. Now of 2 get this value. So just follow it one by one to get the next object and apply the next indexing. The setDefault is a nice function. Let's say that we have here a dictionary, and I observe that I use the integer colon this variable, float colon is this value. If you would like to use a data type, this is okay also, because the data types themselves are mutable. Also observe I used the number 6 several times. This is meaningless because suppose the dictionary would take something to map it to something, but anyway the last value will be used instead of the anything before it. Dictionary of float will give you the value of 10. Dictionary of 6 will give you the last value here, which is 80. If you try to print a dictionary of 7, you will get a key error that 7 doesn't exist. Now the nice thing about the setDefault is as following. The setDefault return the value of the item with the specified key. For example, if I ask it to return the dictionary of 6, it will return the value 80. However, if the key doesn't exist, there are something interesting happens behind the scene. It will insert the key with the specified value. For example, if I printed setDefault of 6 and -8, it first to go and check if 6 exists. It exists, then it just return its value. This -10 has no -8 has no effect. On the other side, if you say dictionary setDefault of 7 and 20, does 7 exist? No. Set 7 in the dictionary with value 20 and return it. Now if you try to return the dictionary of 7, it will be 20. The membership operator, as you expect, is working like the list and the string. You can say if the Ziad in dictionary, it will return true. 100 in dictionary, it will return false. However, notice that this is just a checking in the key itself. For example, if you wrote is 25.5 in dictionary, the answer will be false. This is a check in the keys only. If you try to write something like if dictionary of 7 equal 5, we know that this will give an error if dictionary of 7 doesn't exist. Now here is one interesting use for the in operator. You can write something like if 7 in dictionary and the dictionary of 7 equal 5. This would do that. If 7 is in the dictionary with short circuit evaluation, we keep going. But if this is false, this will not be evaluated. So you are now in a safer side. The get method, if you ask it to get 7, if 7 exists, it will be returned. If it doesn't exist, a none will be returned. So now get has the advantage that it doesn't throw an error for you. In a similar way, you can write get 7 and 15. If 7 doesn't exist, 15 will be used as default value. 7 in dictionary is false. Observe that the two get methods didn't put the value 7 in the dictionary. However, the setDefault function will put 7 in the dictionary. You can also get something like 4 and 6. It will return the list for you. If you try to write dictionary.clear, like anything, when you clear it, you just clear the you unbind all the keys with the values and remove the keys. So this is what happened here. We remove all the keys from the dictionary. The pop-up item. The pop-up item remove the last key value pair added from the dictionary and return it as a tuple. So now looking to here, we enter the X, then B, then Y, then A. If you try to pop up them one by one, while dictionary, when the dictionary is empty, the while will break. It will return A, and then it will return Y, B, X. We will know sooner that the dictionary preserve the order starting from Python 3.7. One of the interesting things here that I would like to highlight in a very small way, As we learned before, there's what we call time complexity, which is a topic that you will study in algorithms, but I would like to do some highlighting in it here. There's what we call an average time and amortized time. When we do a check like K and D, this is most of the time will take O1. In a very special cases, it can actually take up to ON. Remember that O1 means, let's use some constant like 10. O1 means it will take around 10 steps to get things done. ON means it will take like 10 times N steps to be done. This is mainly what I wanted you to notice here. There is some average case and some amortized case. So in general, it would be very close to the list in accessing. But if the dictionary has a lot of elements, it might get a bit slow. Read the other items here, and you will notice this function in the next videos. That's all.